So, hi everyone, and now we have the second part of our second lecture, and this part about cash flows. And first, we would like to consider what is perpetuity and how we can find the present value of perpetuity. Cash flow is just a stream of different payments, but perpetuity is a stream of equal cash payments and at a regular intervals. And it's very important that continues forever. Um, so it is a stream from A, and so on. And how we can find the present value? So how much we can, for example, deposit that have possibility every year have the value, no, for example, A at the end of the every year forever. What is present value? And for this we can find the next equation. Present value at the present value we have at the beginning of the year, and at the end of year we have present value multiplied 1 plus r little, 1 plus r little, and we need subtract a because it is our payment or payment to us at the end of each year, and result present value. What we need to result present value? Because it will be repeat present value at the end of year, at the beginning of year, and at the end of year the same expression, and so on. And from this equation we can get this formula. So this formula, which is formula which define present value for perpetuity, and we can illustrate this formula using this example. This example about UK government war loan. It's console, and the face price. It is price which is printed on the security. So it is face price. It's 100 pound, not dollars, but it doesn't matter. And initial payment 3 pounds. Initial payment, it's our A equals 3 pounds. So we have A 3 pounds, and we have two cases for interest rate, 6 and 3. So if interest rate is 6, so 3 divided by 6%, it will be present value 50. But for this case, this face price, not this, this payment 3, we divided by 3%, and it will be 100. So this present value are different, but the payments will be the same. Payments will be 3 pounds per year. This and this. and the difference is only on this percent. So you can see that the price of this government bond loan is different too. This is 100, but this is 50 pence per pound. So you see that it easy. We only use this formula, and but there are another kind of cash flow, and it's annuity on n years. What is difference? Annuity is a series of equal payments at regular intervals too, but not forever. Only on n years. What is difference? Understand? It's difference. Only on n year. And we would like to find present value too. And for example, we consider that n and capital equal to. So we would like to consider annuity only on 2 years. On 2 years. Annuity on 2 years. So present value at the beginning of the year, and at the end of year will be present value multiplied over 1 plus 2, and we would like subtract a, because n for 2 years means that we have stream A and A only on 2 years, and after these 2 years we would like 0 on our account. So this is first year. Second year we have this value at the beginning of period of the second year, but of the end of year we have this value multiplied as always by 1 plus r. So it will be present value multiplied 1 plus r minus a. It is all this, yes, and all this we multiplied by 1 plus r, and we need subtract this a. So it is this a, yes, it is this a. It is first a, it is second a, and according our rule, the result will be 0. So from this equation in red color, we would like to find present value. So for this we move to the right side and divided by 1 plus r. So we have present value multiplied 1 plus r minus I at the left side, and a at the right side divided by 1 plus r. After that we can move to the right side, it will be, no, I correct this, a plus this ratio, and after that we can divide it both sides by 1 plus r, and the result will be present value equals this divided by this bracket, a divided by 1 plus r plus, and this divided by 1 plus r. So it will be 1 plus r squared. Oh, so we have the false formula. Present value equals a divided 1 plus r plus a divided by r 1 plus r square. But it's only for 2 years. If it will be for n years, so it will be plus a divided by 1 plus r to the power 3 and so on, and the final ratio a divided by r plus r to the power 10. Yes, so we have this formula. We have this formula. 1 plus r to the power k, and k from 1 to n. Yes, but what do you think? How we can get this formula? Christina, what do you think? How we can get this formula from this? Have you any idea?
Like it's a sum of geometric progression. No?
Yes, you're right. You're right. We can use formula for geometric progression, and this is progression from y to n. And we remember this formula in your input test. It will be b1 multiplied 1 minus q to the power n divided by 1 minus q. No, you remember. So if we apply this formula, will be this. And we can compute future value. Future value, it is what will be the sum in n years, and it will be a similar formula, but it is not this factor in numerator, but in denominator, but in numerator, and we can use formula of geometrical progression too, and it will be these two formula for present value and for future value. Thank you. And today I would like to consider term structure of interest rate. You understand that interest rate depends on the term of duration of the loan. It's easy, and you need to distinguish the difference between spot rates, discount rate, and forward rate. What is spot rates? Spot rates, it's interest rates for maturity in T years, and this interest rate is quoted today. So we come to bank, and we know what is this spot rates for different T, because for 1 year can be one spot rate, but for 2 years it will be more spot rates. And in T years we can find present value, and it's understand what is this formula how we can get this formula. For example, we know what is amount of money we would like to have at the end of period. It is A capital, and we know these spot rates, and we would like to find present value, how much we should deposit in order to have a capital at the end of period. Yes, so it is clear, I think. And from this formula, we can denote this as a discount rate, and that's all. But what is maybe new for you, it is forward trade. What is forward trade? It means that if it is time x, if it's time x, and we have and we have time u, and after that time v, and v more than u, and today we are at the initial period, and we know only two spot interest rate for u years, for u years maybe, and for v years. For this we know, and this we know, two spot rates. But we would like to find what is this interest rate, because for example we deposit some amount for u years, but after that we would like to deposit at another account, and we don't know this spot rates, and for it we can denote forward rate fee from u to v, and this we can find from this equation. For v years it is 1 plus r to the power of v. For u it is this bracket, it is the same. And after this we use multiplicate rule. So it's multiplied 1 plus not r but f, we write to the power v minus u. So it's not difficult, indeed. In fact, it's not difficult. Do you understand this formula? No? Christina, do you understand this formula? Christina, do you hear me? Not. Maybe. What's about...
Can you explain again about F U V?
You would like that, yeah, that me explain again, yes?
Yeah, if you
okay,
can.
okay. For example, U equals 2 years, and V equals 7 years, yes? And it's given that R2 3%, but R7 5%. Is it logical? Is it logical? Yes. You know the deposit for more a year, the interest rate is more. Yes. And it's known for today. We know this and this, and we would like to know what will be f from 2 to 7, from 2 to 7. And for finding this, we can solve this equation. 1 plus RV, it is 5%, 0.05, and to the power 7 equals 1 plus what I have to write? Who would like, if you understand?
Plus 3%.
Yes, 3%. And to the power
Of 2.
2. Yes. And multiplied 1 plus f sub to 7. And what is power?
5.
5, yes. So I think you understand, yes? Thank you. So summary. Today we learned formulas for the risk-less financial instruments. Their price depends on time only, and it was such concepts as return, rate of return, logarithmic return, cash flow, annuity, perpetuity, and how we can find their present value, and spot rates and forward rates, what is different. And reference, it is Sheldon and Ross, Introduction to Mathematical Finance, and page 38, 56. So that's all, and you have 10 minutes for your crossword. And our practice lesson is in 11:40. And welcome. I will wait.
And where we can find the crossword?